primitive chordates have a much smaller brain region, although it does contain a medulla-like posterior region. In vertebrates, the medulla lies under the fourth ventricle, but ventricles are absent in primitive chordates. The jawless fish possess much larger brains than primitive chordates, and the medulla can compose half the length of the brain and is its best developed region. It possesses homologs to many aspects of the gnathostome medulla, such as a choroid plexus, the nuclei of cranial nerves, and a number of other homologous nuclei. The gnathostome brain is larger than in jawless fish, and as I cover in the video on the reticular formation, many of the nuclei of gnathostomes and the tracts between these nuclei and other brain regions are homologous when comparing, say, a shark to a mammal. The position, the nuclei, and the tracts of the medulla in primitive osteichthyan fish, in sarcopterygian fish, and in amphibians are homologous, and minor changes which are shared with mammals accumulated. Ancestral amniotes modified the medulla, and there are a large number of features which amniotes share which are absent in tetrapods and in fish. These include the nuclei of the medulla, the tracts of the medulla, and there are no longer any lateral line organs or nerves in the medulla as in more primitive vertebrates. There are a number of features of the medulla which are shared only among mammals, which are absent in reptiles. Placental mammals possess a few modifications of the medulla lacking in therian mammals like marsupials and in the egg-laying monotremes. The earliest primates, the prosimians, share additional features, and then later primates share additional features. And so the medulla has undergone evolution through a number of intermediate steps to produce the medulla found in humans today.